Let's explore sampling methods. What is sampling? From 1.4 billion people, we select 3,000 representatives. That's our sample. See what I mean? We use this sample characteristic to represent the whole population. The sample's features tell us about the entire group. For example, are you all happy? Yes, very happy, they say. That's an example of sample characteristics. This shows us what the whole population looks like. This is sampling. Okay. Similarly, let's say an organization has 1,000 changes. We take a sample of 50 changes. With these 50 samples, we can assess the compliance level of all 1,000 changes. See, that's sampling. Sampling. Compliance testing. Let's talk about compliance testing. We've covered control testing already. What's the key point here? The matter of liquidity. Do they follow organizational procedures? Do they comply with organizational policies? Okay. So compliance testing primarily checks if management policies and procedures are being followed. You'll see this on the exam. Particularly how well the defined processes work. Let's look at some examples of compliance testing. User access permissions. Software license modifications. These are all compliance-related matters. Checking regulatory compliance. That's what compliance testing involves. Substantive testing, also known as detailed testing. The main focus of substantive testing is data integrity in individual transactions. Correct. So substantive testing focuses on specific numerical values. Isn't that right? We test the actual numbers in transactions. Compliance testing determines whether procedures meet regulatory requirements. When it comes to substantive testing, it involves complex calculations, like interest calculations, and things like that. Ledger transactions. How these elements connect. Whether compliance controls are working properly. Okay. When internal controls are strong, we can reduce substantive procedures. See, with such effective controls in place, we can minimize our substantive testing. However, if internal controls are weak, have deficiencies, what becomes our primary focus? Substantive procedures. And specifically, sampling. This is verbatim from the exam question. Sampling. What do we mean by sampling? It's using sample characteristics to draw conclusions about the whole population. That's the exact wording. It's straight from previous exam questions. Now, in sampling, there are two main methods. First, statistical sampling. Second, non-statistical sampling. Here's an example. What is statistical sampling? Okay, let's say we have 100 items, and I need to sample 30 of them. So what exactly is non-statistical sampling? It's also known as judgmental sampling. Wow, I'm a seasoned expert. What I mean is, I know this work like the back of my hand. Just by glancing, I don't need to examine all 30 samples. Just 2 will tell me everything I need to know. Just by looking, I can quickly assess a company's internal control systems, management practices, operational procedures, and identify potential process deficiencies. This approach is known as professional judgment-based. Non-statistical sampling, or judgmental sampling. Indeed, this method uses quantitative metrics. Let's talk about subjective judgment. Here's the question. Which approach would you say works better? Now, listen carefully. Some might argue that statistical sampling is more objective. However, if someone inexperienced conducts statistical sampling, the results might not be reliable. So don't rush to dismiss judgmental sampling, thinking it's inferior or unreliable. You see what I mean? Like in my previous example, I'm a true expert with years of experience. I can immediately identify where the issues lie. Therefore, each of these methods has its advantages and limitations. What characterizes statistical sampling methods? It employs quantitative criteria. But these quantitative criteria are essential. In the sampling process, the first key method is attribute sampling. Attribute sampling is a crucial examination topic. How do we define attribute sampling? It's typically applied in compliance testing. It examines the presence or absence of specific attributes. As I was saying, all management processes require proper authorization. Either it exists or it doesn't. Whether authorization is present. You'll see, every control measure must meet compliance standards, whether it meets standards or not. And we call this attribute sampling. It is primarily applied in compliance testing. Hence, attribute sampling is also known as fixed sample testing. It quantifies the occurrence rate. Indeed. Very well. In terms of population characteristics, the frequency of attribute occurrence. Take the change management process, for example, where the compliance rate is 95%. This exemplifies attribute sampling. This is known as statistical sampling. Let's examine what this means. Also called statistical sampling. Let's look at the definition. It enables early termination of audit testing, preventing excessive sampling of attributes. So what does that mean? Well, let's say we have a company with excellent internal controls, performing exceptionally well, particularly in their change management processes. But with a total population of 1,000 items, let's start by sampling 5 items. If these 5 samples are clean, we can conclude the testing. What do we call this method? The statistical sampling method. Is that clear? Alright. That's our statistical sampling. Remember this, it's definitely on the exam. Don't worry, these concepts are fairly straightforward. Next is discovery sampling. It's very likely to appear. There's an 80–90% chance it'll be on the test. You'll often see questions about discovery sampling on exams. Pay special attention to discovery sampling. It's similar to how internal affairs investigations work. Think of it as an oversight committee. Let me explain how these investigations work. When someone is reported for misconduct, what happens next? We keep investigating until we uncover the evidence. There's no stopping until we find proof. We never give up. You see what I mean? That's the essence of discovery sampling. I'm convinced there's fraud here. I won't stop until I find proof of fraud. That's what we call discovery sampling. When an audit aims to uncover fraud or regulatory evasion, or other violations, discovery sampling is our go-to method. If the sample is clean, we assume there's no fraud. However, if we find even one error, the whole sample is marked as fraudulent. So, as I was saying, someone filed a report about suspicious activity. Isn't that so? We need to thoroughly investigate any potential irregularities. This is known as, if an error is found, the entire sample is deemed fraudulent. Discovery sampling. What's the main purpose of discovery sampling? It's exactly this: to detect fraud. Which sampling method is most common? Discovery sampling. Second is variable sampling. Attribute sampling for compliance testing. Variable sampling comes into play during substantive testing. It helps us examine populations with varying characteristics. You'll see, this is particularly useful for monetary values. Applies to weights and other measurements to identify deviations from the norm. Makes sense. Take your general ledger for instance. We need to measure how much the values deviate. Say there's a $500 discrepancy. Follow me. We need these precise numerical values. Got it. Okay, let's identify any missing elements. Take $100,000 as an example. You need to specify the exact amount. Variable sampling has alternative terms. It's known as dollar unit sampling or million per unit sampling. This method primarily applies to quantitative measurements. This detailed testing approach is applied to currency and similar measurements. Regarding variable sampling, there are 3 key concepts to understand. When it comes to examination topics, stratified sampling is frequently tested. Let's define stratified sampling. Let me give you an example. Let's say you're doing a survey. What's the survey about? You want to know what men like to do, their interests and hobbies. But then you realize, from infants to elderly men in their 80s, They all have completely different interests. Sure. You need to divide these men into different groups. Makes sense, right? Like, what do men in their 30s like to do? What about guys in their 20s? What interests do men in their 20s have? Then those in their 40s. See what I mean? Those in their 50s. And those over 60. Right. This is what we call stratification. Makes sense. So why do we stratify? In our statistical model, the total population is stratified into distinct groups. Once we have these groups, we take samples from each group. This method is what we call stratification. Stratified sampling. We look at the unit mean values. So what makes stratification beneficial? Your findings become both more accurate and precise. Makes sense, right? Now, you might wonder when to use stratification. When we don't use stratification, let's look at the overall valuation approach. So when do we use each sampling method? For control testing, we use attribute sampling. Makes sense, right? For substantive testing, we use variable sampling. Now, let's cover a few more key concepts. Speaking of these concepts, the centroid coefficient in the exam context is an extremely rare exam topic. It hasn't shown up in the past 56 years, though it has appeared before. What is a centroid coefficient? Let's revisit this concept. From my perspective, don't dismiss the CSA textbook as incorrect. You haven't reached that level of expertise yet. So trust the textbook's definitions. It's a challenging concept. Many students struggle with this. Even CISA certified students often misunderstand it. The textbook is authoritative. So what exactly is a centroid coefficient? Here's an example. Let's say, if you were to recommend me, Wu Xiaofeng, to your friends, or make a social media post, saying something like, Wu Xiaofeng is highly reliable, trustworthy, and a person of integrity. Here's the thing. In auditing, what we need to focus on is a specific coefficient. How reliable is the data, exactly? Wouldn't you agree? When asserting data reliability, you must be accountable for your assessment. Is that clear? Your published conclusions carry responsibility. Let's say you determine a confidence level of 60%. Consider this. In this case, when presenting your findings, your assurance only extends to that 60% confidence level. Does this make sense? So you spent time trying to verify Wu Xiaofeng's performance index of 60%. And what happened? You only spent 20 minutes doing some basic research. And called it done. Now think about it. Is 60% high or low score? It's obviously quite low. Definitely on the low side. Therefore, you published a report saying Wu Xiaofeng's performance score was only 60%. Isn't that so? So that's what you're saying, correct? When you dealt with him, I'm only responsible for my investigation, which showed a 60% reliability rating. But I only did a 20-minute background check. If you claim Wu is highly reliable, with a 99% reliability score, well, then you need to back up. That 99% claim, with some guarantee or accountability. So how can you prove that Wu Xiaofeng is 99% trustworthy? Here's what you might do. You'd visit the village where I was stationed and interview all my acquaintances there. Wouldn't you? You'd question every single person who could talk, asking about their experiences with me and any questionable behavior. But you wouldn't stop there. You'd then investigate every workplace in my career history. Correct. You took samples from each department, running background checks on 20 to 100 people. Didn't you? Throughout my 20-year career, you investigated everyone I worked with. Isn't that so? Let's say, about 1,000 people. Alright. But that's still not enough for you. You'd go to any length. Going back 3 generations. You know, I traced all the family lines. Every family member. One by one. Checking if there were any patterns of genetic traits in the family line. This research took about 6 months. Before publication, based on my investigation, Wu Shaofan's confidence level is 99%. In my report, I stand behind the 99% confidence level of my findings. This is an example of what we call statistical reliability. What's the inverse of reliability? We call it risk. But what does that mean? If we have a 99% confidence level, then the risk is the remaining 1%. So, what's our failure risk? 1%, right? Now, if our confidence level is 60%, what's the failure risk? Wow. The risk is 40%. Alright. Now here's a question. Let me ask you this. The decision to revise depends on your investigation. It comes from your testing procedures and verification results. Keep in mind this coefficient. Understood? The 1% risk level, or the 40% risk, these are proven through testing, not just calculated. These practical stats are essential. Is that clear? Alright. That's our first point. Second, let's say you find Wu Shaofeng trustworthy. Based on feedback from his associates. When conducting a follow-up audit, you can apply a different approach by setting an 80% confidence threshold for the review. Isn't that so? Your investigation and verification are aimed at meeting the 80% reliability threshold. You're only accountable for that 80% threshold. Makes sense. With an 80% confidence level, how much work would this require? It means less work for you. See, but let's say Wu Shaofeng, when assessing their credibility rating, I assigned them a 95% rating. Wouldn't you agree? With a 95% score, that's considered quite a high rating. Now, should we use a large or small sample size? Definitely large. Since you're backing up such a high 95% rating, you'll need substantial background research to support it. What does this tell us? There's a direct relationship between credibility ratings and sample size. With lower credibility scores, this results in a smaller sample size. When reliability is high, we need a larger sample size. Whoa. Because you're responsible for the final reliability assessment. Now you see how reliability affects sample size, right? Let's return to the formal guidelines. If internal controls are strong and well implemented, what's the next step? Lower the confidence level. Why is that? Well, as I explained, when you lower the confidence level, you'll need to do less audit testing and verification. Makes sense, right? On the other hand, if you find weak internal controls, then you need to raise your testing threshold to ensure report reliability. Wouldn't you agree? You'll need to increase the level of scrutiny When you increase the confidence level, the required sample size increases substantially. This shows how confidence levels affect sample size. Remember, your conclusions must support your chosen confidence level. All your testing procedures must align with this confidence level. So firstly, with a higher confidence level, you'll need a larger sample size. This is a crucial concept to grasp. Risk level equals 1 minus the confidence coefficient. Let's move on from this point. Now, regarding sampling risk. What constitutes sampling risk? When an auditor draws a conclusion, it may differ from testing the entire population. That's what we call sampling risk. Let's look at the two types of sampling risk. First type, incorrect acceptance, also known as false positive, where major issues are wrongly deemed insignificant and go undetected. Second type, incorrect rejection, when there are no significant issues, but they're flagged as major problems. In reality, no such occurrence was detected. The assessment indicates a potential risk of occurrence. This is the fundamental principle.